All right. So number one, on our review for test number 4 here, what do you see as far as solving that we'd need to do? Which method? Well, we could go probably either way here, but probably the way it's set up, elimination, right? We're going to use a little bit of elimination method. And so eliminate one of the variables here. And either one, basically, I think the x's look, the x squareds look more promising. All I'd have to do to eliminate the x squareds would be multiply by -2 on top. So multiply by my -2, I'm just going to do it this way. So that'll give me a -2x squared on top plus 2y squared equals -18. And then the bottom would be 2x squared minus 3y squared equals 1. Stays the same because that will eliminate my x squareds. 2y squared minus 3y squared is minus 1y squared. And that equals -17. And so divide through by the -1, and we've got y squared equals 17. And so what about y there? Square root method? Square root both sides, so we get y equals square root of 17. The only thing is it could be plus or minus square root of 17. All right, so that is half of the answer there. I do need the x, so I need to plug in, basically plug in that, the square root of 17 for y there, so I'd get x squared, or the other one, x squared equals the square root of 17 squared equals 9. We'll just leave it square root of 17. Could round off, I guess. But if I leave it as the square root of 17, what is the square root of 17 squared? That's just 17. And so we get x squared minus 17 equals 9, which means add 17, and we've got x squared is 26. And so what is x? Square root of 26 plus or minus that. Of course, the other thing is I do have a negative square root of 17, but if I note, if I do a negative square root of 17, nothing changes, does it? Because the square root of negative square root of 17 squared is still positive 17, so I still wind up with. So here's the deal. Either way I go, plus or minus square root of 26, plus or minus square root of 17, those are my 4. There's 4 answers there. Plus or minus the square root of 26 goes with both the square root of 17 and negative square root of 17. So we can write it like that. With me? Question or concern? All right. Number 2. Number 2 looks like to me, what does it look like to you? Substitution. Yeah, because I can take this y equals x minus 2, and I can substitute that for the y in the first one. So I get x squared plus x minus 2 squared equals 100. And so that'll give me x squared plus, now remember this is x minus 2 twice, so that would be x squared minus 2x minus another 2x plus 4, because I have to FOIL that out right there. That equals 100, which on the left gives me 2x squared minus 4x plus 4. That equals 100. Now, what about that? Solve that. Need to make one side 0, don't I? Subtract 100 to make one side 0. So you got 2x squared minus 4x minus 96 equals 0. And to make it a little bit nicer on us here, I can divide everything by 2. So you get x squared minus 2x minus 48 equals 0. So far, so good? All right, well, that factors the x squared minus 2x minus 48 does. X and x for x squared, 48 minus, with minus 2 in the middle, minus 8 and 6, positive 6. So x minus 8 equals 0, that'd be x equals 8. X plus 6 equals 0, that'd be x is negative 6. So again, I get 2 answers there. So I need the y's to go with those. So I plug in x to be 8 in the y equals x minus 2 equation, that would give me y equals 6. If I plug in x to be negative 6, I get y equals negative 6 minus 2, so I get y equals negative 8, 8, 6, and negative 6, negative 8. My two solutions there. Okay? All right, what about number 3? Find the points of intersection for the graphs of the following. Well, I point this out here because what about points of intersection? What do we know about points of intersection and how it relates to something like this? If you consider this a system, what are the points of intersection? It's the solutions. Yeah, it's the solutions to the system. So vice versa, solutions to a system are the points of intersection on the graphs, the real solutions. Yeah, so if it asks for points of intersections, again, it's just solving the system, which, again, it looks like substitution, doesn't it? I can substitute the minus 5x minus 1 for the y down here, so I get minus, I did that way, but minus 5x minus 1 equals 2x squared minus 4. Again, it looks like I need one side 0. Make one side 0. Let's make it the left side here. I'm going to add the 5x and add the 1. And so I get 0 equals, what would it be, 2x squared plus 5x minus 3. Factor that one up. 2x, x. I believe it's 3 and 1 with the 3 there and the 1 there. And it's a negative 3, so I need this one negative and this one positive. Yeah, that gives me 6x minus 1x if I full it, right, which is 5x. With me? So that would be 2x minus 1 equals 0, or x plus 3 equals 0. Here if you add 1, 2x equals 1 divided by 2, you get x as a half. Here you get x equals negative 3, of course, but again, we do need the y answer with that. So if x is a half, we'll have negative 5 times a half minus 1, which is negative 5 halves minus 1. Negative 2 and a half minus 1, that's negative 3 and a half. Or negative 7 halves, right? Did I do that right? If x is negative 3, we'll have y equals negative 5 times negative 3 minus 1. So that would be y equals 15 minus 1. That's 14. So my two answers there, two answers again. 1/2, negative 3 and a half, and negative 3, 14. Did I get those right? Did I do something wrong there? That's what I got. Got that before, so I'm okay. All right. All right. We also did talk about this fourth one here. Three equations, 3 variables, and the way we did one like this was, well, we've got this second equation here that's got x and z in it. So if I can make these two, get rid of the the y, eliminate the y on these two, that would give me a good equation to go with the xz equation on the bottom there. So I'm going to eliminate the y's, which is going to be fairly not too bad to do, right? Just to get rid of the y's here on the first two, multiply by 3, top one, 3x plus 3y plus 15z equals negative 18. To go along with the 2x minus 3y plus 2z equals negative 1. Again, like I'm saying, I'm eliminating the y's on the top two, because that'll go with the third one. Doesn't have a y in it. All right, well, that gets me what? 5x plus 17z equals negative 19. All right, and so put that with the x minus 7z equals 17. That helps me because now I can just use elimination again, can't I, to get rid of, or substitution, either one. But if I go with elimination again, I can eliminate the x's. All I have to do is multiply by negative 5 on the bottom. So I have 5x plus 17z equals negative 19. But on the bottom, I'll have negative 5x plus 35z equals negative, is that 85? The x's eliminate. So I have 52z equals negative 104. Hey, that works out nicely. Z is negative 2. Well, if z is negative 2, then I have x, plug it, the negative 2 in for z back there, so I have x minus negative 7 times negative 2 equals 17. Yeah, I can figure out what x is. That'd be x plus 14 equals 17. Subtract the 14. Got x is 3. Right? And so then I've got x is 3, z is negative 2, so I can plug it in to go back to one of the original ones there. X is 3, y I don't know, but I do know z is negative 2, so I can figure out the y. Right? It'd be 3 plus y minus 10 equals negative 6, so that's y minus 7 equals negative 6. Hey, yeah, that's add 7, y is 1. So my solution, x is 3, y is 1, z negative 2. Sound right? Believe that? All right. We did talk about a couple of word problems. Here's one of them. Alex wants to invest $50,000 in 2 accounts. One will earn 6%, the other 8%. If he will earn $3,200 total annual interest, how much is at each rate? Yeah, we set this up as a system because, yeah, we've got 2 things we know. We know about the total, and we know about the interest. So we do a total equation, x plus y equals 50,000. And then we do an interest equation. Well, we take each percent, 0.06 times the amount x, and then the other is 8%, so we take it times y, 0.08 times y, and that equals the 3,200, the interest. Because we're talking simple interest, so we just take the rate times the amount, and that's the interest. Okay? So here, if we do a little adjustment, subtract x, we've got y equals 50,000 minus x. I believe that's the way we did them, so you can do them in elimination as well if you want to. But if we use substitution, yeah, I'll just plug this in for y right there. So we have 0.06x plus 0.08 times 50,000 minus x. That equals 3,200. So that'll be 0.06x plus 0.08 times 50,000 is 4,000. Minus 0.08x equals 3,200. The x's, we've got negative 0.02x. I'm going to subtract the 4,000, though, from both sides. Negative 800. Negative 0.02x equals negative 800. Divide off the negative 0.02. And that is, x is 4,000. I do believe. Does that sound right? Believe that? I think so. So if x is 40,000, sorry. Let me check it, just to be sure. It's 40. Okay. Thank you. So if x is 40, yeah, the y is 50,000 minus that, so it'd be 10,000. So the 40,000 is at 6%. The 10,000 is the 8%. Is that okay? All right. Real quick here, number 6. We also graphed systems of inequalities, and that just means a little bit of shading. So let's talk about the x squared plus y less than or equal to 9. Yeah, the first thing you want to do is graph the equation associated there. X squared plus y equals 9. Well, that's going to be a parabola. Yeah, if I subtract my x squared, I can see that's a parabola inverted, shifted up 9. So that's going to put my vertex up here at 0, 9. And again, if you wanted a couple of points there to go with that, the vertex of 0, 9, you can do your -1, +1, but in both cases there, -1 plus 9 would be 8. Same thing there. So yeah, that one's just right there and right there. You can get a couple more if you want, but there's my parabola. Opening down 0, 9 vertex. Okay? However, the inequality there adds to it a little bit of shading. How do I determine the shading? Well, you check a point not on the graph. 0, 0 is usually a good choice if it's not on the graph. So plug that in for x and y there. 0 squared plus 0 less than or equal to 9. Is that true? 0 is less than or 9? So that would mean shade 0, 0 where it is, which is inside. So I'd be shading inside here. Let me just make note there. It would be the inside. All right, what about 2x minus y is less than or equal to -1? Well, that would be a line with shading. Let's see if we move some things around. Let's just move this over there and that over there. So it'll be 2x plus 1 equals y, or y equals 2x plus 1. That's a y-intercept of 1. Slope of 2, so rise 2 runs 1. Right? It's my y-intercept. It's my slope. 2 over 1. That's what I did. So there's my line. And I am drawing these solid because I have the equal to part. The shading on it, checking 0, 0, 0, 0 work. 2 times 0 minus 0 is less than or equal to -1. 0 is less than or equal to -1. False. What does that tell me? That tells me to go to the other side, away from 0, 0, so that would be above this one, wouldn't it? So it's above the line and below, so right now it's the inside of the parabola and above the line, but I have this third one. What about that? Y is less than or 8. Well, y equals 8, that's a horizontal line. X equals is a vertical, but this is a horizontal. And it's dotted because I don't have the equal to part, so it's a horizontal line at 8. And I want less than that, so that's below the line. So below the line, inside the parabola, isn't it this then? That would get all those things.